We're going to take a look now at topic 7 of chapter 8, where we deal with more about graphing quadratic functions. Now, this is the standard form of the quadratic expression, and this can be modified into this formula, which I'm calling the Vertex Formula. And you might say, why am I calling it that? Well, because from this, you can actually pick out the vertex, and the vertex is usually described as h, comma, k, and you'll see it can be picked out of this formula. Now you might say, well, what is the vertex? Well, as you graph this expression in a function form, you get a parabola. And as you make the parabola, you'll find that there will be a point on the parabola which is the bottom point of it, the lowest point on the parabola. That is the vertex. And the letter K will indicate what that point is in terms of, in this case, the minimum, with the parabola opening upward. If you have a parabola that's opening downward, then the vertex is on top, and that point would be the maximum, since it's opening toward the bottom. Now, we'll give you some more about this, and perhaps another word I should put in there is the axis of symmetry. And the axis of symmetry is the H unit. Now, keep in mind this is an ordered pair, so in a sense this is x comma y, and your H, which is your x value, is your, in this case it's sort of like that, in this one it would be like so. So a couple of things going on here in this section. Some of it might be review, but let's get on to example number 5, which is to take this formula that's in this standard form and put it into the vertex formula. Now there is a way to do it, and that's what I'm going to show you as we go through this. Step 1 is to have the form in standard form of the quadratic expression. Step 2 is to rewrite it. But now take the C term and move it out here. Now, what we're going to do is try to take this part of it, and using the technique that we had in section 8.1, completing the square, work on completing the square. Now, what we did when we gave you that lesson earlier was to put a parenthesis, and we knew it was going to be squared, a binomial that was going to be squared. And we want to make this into a perfect square trinomial. Well, we knew the x came down here, and the sign is plus. And then what we said is you look at the b term, and in order to get this term here, you had to take half of the b term. Well, half of 8 is 4. Then we did something to complete the square, we then wanted to get our C term, and we get the C term by squaring this term, which we did. And this made what is called now a perfect square trinomial that will factor into this. But as a special technique and a sort of modifying the completing the square, we're going to do an interesting thing here. We're adding 16, but we're also going to subtract 16. Now, when you do these two things together, that's a 0, and in a sense, you're back to your original expression. And what we're doing here is we are, in a sense, putting a parenthesis around this now and say, factor that perfect square trinomial into this binomial that we're going to square. But we still have that negative 16 out there, and we have the negative 5. Now what do we do? Well, we sort of summarize this, and we get x plus 4, the quantity squared, minus 21. And now we have this in this vertex formula, where A is going to be a positive 1 that we don't write, and x plus 4, the quantity squared, minus 21. Now I said from this, you can pick out some stuff. For instance, what would be the vertex then of this parabola? Well, an interesting thing happens. Notice this is a positive h here, and in this formula it's the opposite of that. So when we write the vertex, we have to take the opposite of that positive 4. What is the opposite of a positive 4? Well, a negative 4. And this then is just the k, which is a negative 21. So this happens to be then the vertex. Now the axis of symmetry of that would be a negative 4, and the minimum is going to be a negative 21. Now we're giving you a little bit more information than what they're asking for this, but you'll see as we go along, it all fits in. As we look at example 6, again it's a function of a quadratic expression, which will turn into a quadratic equation in a sense. And we want to put this formula that's in standard form into the vertex formula here. And we're going to use the technique of completing the square. So step 1, you have it written out properly. Start to write it again. We're going to move the C term out here temporarily. Now, using this part, which is this part there, I'm going to start to complete the square. Now, I know that x squared just becomes x here. I'm going to use this negative sign right there. And then now I want to find out, in terms of b, what do I put here? Well, it's half of b. So a negative 3 times 1/2 of b, gives me a negative 3/2. So now I'm going to take my, and then this is going to be squared. I'm going to take my negative 3/2 and square it to get my C term. So this becomes then a positive 9/4. But again, the special technique that we're using is we're also going to write a negative 9/4. Now notice this is exactly this, because this is 0. But I'm using it for this technique. So I'm now going to put a parenthesis there, and this is what I'm factoring into my binomial that I'm squaring. And now I have to add these two together. So this is going to be a negative 9/4 plus, now I can't add the 2 to it yet because it doesn't have the same denominator. So I'm going to take that 2/1 to make it a denominator with 4. Multiply that by 4, multiply that by 4. 4/4 is 1. I can multiply anything by 1. This then becomes 8/4. Now that they're common denominators, I can do my, in this case, subtraction. And my n item becomes x minus 3/2, the quantity squared, minus 1/4. Now, let's, again, I'm not asking for it here, but let's give the vertex of this. Well, vertex is opposite sign of h, which will be 3/2. And my k is my y value, negative 1/4. So there is my axis of symmetry. There is my minimum. And that's this. Now I'm skipping one, but they're done in a similar fashion. I'm not going to do them all, it would be too long a tape. But this one's a little different because now my first term here is negative. And in order to complete the square, we want our coefficient of x squared to be a positive 1. So we have to do a little something with this. So I'm going to rewrite it. I'm going to move this term out here to the side because I want to work with this. Now I want this a term to be positive for now. So I'm going to factor out of this a negative 2. That changes this side and becomes just plain x squared. But this now becomes a negative 1/2 x. And again, I'm just fiddling with it a little bit here. Now, what I want to do is I'm going to try to find what my C term will be up here, or over here. So this is going to be an x. The sign is going to be negative. And now I have to take 1/2 of my B term, which is a negative 1/2. Well, a negative 1/2 times 1/2 is a negative 1/4. And this will be squared. And now we go on to our next little part. We want to find our C term. We're going to square this. Well, this becomes a positive 1/16. But according to our technique, we're also going to put here a negative 1/16. So that makes this 0. That's my negative 1/4 there, or negative 4. Okay, now to factor this, I had to put my parenthesis here, separate this, and then factoring this trinomial, it becomes this. But since I took out my negative 1/16, I have to also put here a negative 2 times a negative 1/16. This is the little tricky part here. And then my negative 4 is still there. Okay, so what's the next stage? Well, this part stays the same. Negative 2, x minus 1/4 the quantity squared. Now, this is going to be a negative times a negative, so this is going to become a positive something. Now, it's going to become a positive 2/16, and a positive 2/16 can simplify to 1/8. But now I have to add this negative 4 to this. And like we did before, I can't add something with the denominator of 1 to something with the denominator of 8. So I have to multiply this by 8. And this is going to give me then a negative 32/8. Now I can add it. So what does this become? Well, it's going to be this, negative 2 times x minus 1/4 the quantity squared minus 31/8. And there, this now is in the vertex formula. And again, since it's in the vertex formula, what would the vertex of this parabola be? Well, it's going to be opposite sign of this, 1/4, and this. Now, an interesting thing happens here. Since my A term happens to be negative, this is going to be a parabola that opens to the bottom. So this vertex is now the maximum. So this is the maximum. Because our A term is negative, it's going to be a parabola that opens to the bottom. And this is our axis of symmetry. And this is our, as we said, the maximum. Okay? We're not going to be asked to graph any like this. The ones that we have to graph are a lot easier. But I thought this one was a good example of when it gets a little bit tricky, and we've done it step by step. Hopefully it will be useful for you. As we do example 9, they're asking us to find the vertex and the minimum or maximum and then to graph it. So this is a little combination going a little further. But again, we're going to put a standard form trinomial into this special vertex formula. So it should be getting a little familiar with what we're doing now. Write it again. Move the 3 off to the side. Here we're okay, we don't have to factor anything out. We're going to put our parenthesis. X goes there. Half of b is 1. We're now going to square the 1. And this gives us a plus 1 here. But according to our technique, we're also going to put a negative 1. Now again, this is exactly the same as this. We haven't changed any values. We're just using this technique. We then put a parenthesis here. We then factor this into that, and we now have this. So this will become then x plus 1, the quantity squared, plus 2. Now what will our vertex be? Well, our vertex will be the opposite sign of this, negative 1, and our k value, which is 2. This is our vertex. And since A up here is positive, this will open upward, and this will be our minimum. Our axis of symmetry is this, and our k is our minimum. So what I've done to save a little bit of time is, since I know this is going to be one of my points, I've put that right there. This is the vertex. And then I chose some other points. And you might say, how did I do that? Well, actually I used my graphing calculator, and I got some ideas of points, and then I tried them and they worked. I'll let you do that. So let's practice now plotting this. Negative 1, 2. So a negative 1, I guess I didn't put any points here. A negative 1, 2 is going to be right there. That's my vertex. Then I have a negative 2, 3. And I have a 0, 3. 0, 3 right there. And you can see I'm starting to get my curve there. Negative 3, 6. So negative 3, and then 1, 2, 3, 4, 5, 6 up here. Sort of like that. And then a 1, 6 up there. So as I start to sketch this, there's my parabola. Again, there's my minimum, and my axis of symmetry, we said, was a negative 1, which is just about like that. Okay. Again, it takes time to do these. What we featured in the beginning was how to convert from this form to this form, and then picking out your vertex, opposite sign, and that's your other value. And then we're working in a little bit to graph them. As we do example 14, again, we're asked to convert from this formula to the vertex formula, find the vertex, find the axis of symmetry, find the maximum or minimum, and to graph it. Well, for those of you that have your TI-83s, and graphing calculators, why this is sort of an easy thing, but others, it just takes time, and so I'm not going to do any graphing anymore. I'm going to work on this skill here. So what we've said so far is to write it again, but take the C term and move it out to the side here. We're going to deal with that later. Now we want our A to be a 1, that's in here, so we're going to factor out a 3, and we get x squared plus 2x. And we're going to leave some room there. And I'm now going to work on completing the square. So we bring our x down, our plus. Half of 2 is 1. That was an easy part. So now what we're going to do is square the 1 to get our C term, which becomes then a 1. But to keep this such that it doesn't change the value of this, I'm subtracting a 1 as well. And now what I'm going to do is factor this trinomial to get my binomial that's squared. And keep in mind the 3 is still there. And now I have to take this 3 and apply it out here as well. And now I can bring down my -2. So to finish this, I get 3 x plus 1, the quantity squared. This is going to be a -3, and a -2 will give me a -5. So, what is my vertex? Well, opposite sign, -1. My k is the y value. So there is my vertex. Now, as we look at it, is it going to be opening upward or opening downward? Well, as we look at our A term over here, this is positive. If the A term is positive, it will open upward. So this will be the minimum, and this will be your axis of symmetry. And again, if you have a graphing calculator, you can get to see what the graph looks like. Again, I'm not sure how many the teacher will ask you to do, but I want you to be able to know what you're dealing with and what it's all about. All right, we're going to change gears a little bit here as we do our last example. Number 19. Here we have a function of a quadratic that's in standard form. And what they're asking us here is to find the x and the y intercepts. That is, when you have a parabola, the parabola is going to cross the x-axis at this point. That's its x-intercept, and there's usually 2 of them. What is the value for y here? Well, the value for y there is 0. And then it'll usually cross the y-axis as well. And it crosses it at this point there and this point there. Well, what is the value of x at this point? And the answer is, that's 0. So this gives us the form of the x-intercept, which is a comma 0. And we have 2 of them for a parabola. And 0 comma b for the y-intercept, and we have one of those. So that's what we're looking at. That's a little bit of the background. And here's our equation. Now we want to solve this for zeros in a sense. So if we put and rewrite this as x squared plus 6x minus 1 equals 0, because this is going to be our y value here. The way we said we solve it is we transpose the c term and that makes it a positive 1 there. And then this is a good candidate for completing the square. So we'll put our parenthesis squared, the x goes there, the plus goes there. We take half of b, which is 3. We square the b, well, the 3, to get our c term, which is 9. And to keep this an equation, we have to put the 9 on that side as well. So we then have this, once we factor it, equals 10. Then we take the square root of that, plus or minus the square root of 10. This then becomes x plus 3 plus or minus the square root of 10. We transpose the 3. On this side it becomes x equals a negative 3 plus or minus the square root of 10. And there are my answers. So we get 2. We get a negative 3 plus the square root of 10. We get a negative 3 minus the square root of 10. And those are our x-intercepts. It's where the parabola will cross the x-axis. Now, we want to find out what is our y-intercept. So when that happens, our x is 0. So we go to our original equation and say, here x is 0. Well, 1 squared is 0. This is 0. And this is a negative 1. So here we're saying our y, remember we could substitute a y there, y equals negative 1. So this is our y-intercept. Again, there's lots of stuff going on. This was rather challenging, I thought, but little by little, if you work it, and I'm assuming you're getting ready for your Chapter 8 tests. Good luck to everybody, and hopefully this was helpful.